My name is Dr. Octria. I'm in charge of the GALLANT project, especially in the work package 1, where we are dealing with the climate adaptation to mitigate or to alleviate the flood risk along the Clyde corridor. So what I'm working specifically is the numerical modeling of the flood along the Clyde corridor. So in the simpler terms, we have quite a digital version of the Clyde with the different elevation, the city, the houses, the woodlands, and so on. And also we can put the water into the model. And by having that, we can play around in terms of the flood risk, where the water will go and when the water will go and how fast the water will go, because this model is physics-based. So we can rely on this one to publish the flood risk map. And what we're trying to do is to add the nature-based solution to try to alleviate the flood risk along the Clyde corridor. And the interesting thing about the Clyde is that we, in terms of the flood risk management, sometimes we treat the Clyde as a river. But actually, Clyde is an estuary, which has totally different morphological feature or different shape than the river, and different physics or different mechanisms of how it operates. And of course, it will relate directly to the flood risk extent or the physics of how the flood can happen along the Clyde River. So the easiest way to see it is that in the river system, in any river system, most of the time, the water goes from the higher ground to the lower ground. That's a very simple physics, yeah? But in the estuary, because the water goes from the upstream or to the uphill or from the higher elevation to the lower elevation. But in the downstream part, in the lower elevation, we have the sea. And the seawater really complicates the physics behind the estuary. That makes, and this is how the estuary is totally different system from the river. In the river, we can expect that the water will come in one direction, from upstream to downstream. But in the Clyde, the estuary system, sometimes the water can come from the upstream to downstream, but because we have the tidal that is going up and down, the sea level or the seawater is going up and down, at some point the water can slow down, and when the tide is very high, we can have the reverse flow coming in from the sea to the mainland. That kind of differences in the physics of the estuary will then relate to how we deal with the flood, because flood is basically where the water goes to the area that we don't want to get flooded. But naturally, the water will go there. So to naturally understand that, we need to understand how the estuary should work. And I guess that's the importance in terms of the physics or how it operates should be taken into account in how we manage the flood along the Clyde River. So the unique thing about the Clyde River is around the Glasgow Green, we have kind of like a gate that holds the water coming in from the higher elevation or higher ground coming into the Clyde River. So this gate basically keeps the flow to hold the flow so that we don't have more water coming in from the upstream to the downstream. Why? Because in terms of the flood risk, if we don't have this tidal weir, we have the more water coming in from the upstream tributaries or smaller channels coming into the Clyde. So it means that it will increase the water level along the Clyde River. So that kind of water should be hold in place, so the water doesn't really add more into the Clyde corridor. But the interesting thing about these tidal weir We are still investigating how it relates to the floodways along the Clyde corridor. We are still working on it, but so far from what we understood, because we don't have anything coming in from the river upstream of the Glasgow Green, it means that the water from the Glasgow Green to Greenock, for example, or along the Clyde estuary, it's kind of like quote unquote a swimming pool, because we don't have a flow coming in from the upstream to downstream. It's highly controlled by the water that goes up and down 2 times a day because of the tidal effect. So it's kind of like a big swimming pool that goes up and down every day. So the way we manage the flood or the flow, it's quite challenging. So it's totally different from the river system, where we have one flow coming in from the upstream to downstream, and if we give space for water to go, as long as it doesn't go to the population's houses, it's fine. But in the tidal system, in the estuary, the water is kind of like going up and down all the time. And don't forget about the volume of the water. In the river system, we have the volume of the water that is finite or limited, coming in from the upstream to downstream. If you can hold a part of that volume, you will reduce the flood risk. But in the tidal system, in the estuary system, we are dealing with the seawater. We are connected to the whole sea, basically. So it means that the water is infinite, just going up and down with the limitless amount of water. So the way we deal with the flood risk is completely different, and we are still working on it, on how the nature-based solution can help reduce the flood risk.